Hello guys, welcome back to the new lecture series on non-deterministic finite automata. So all these days we were discussing on the concept of deterministic finite automata, and in today's class we are starting with a new concept which is called non-deterministic finite automata. So now let us see what do you mean by non-deterministic finite automata, which is also called as NFA. In the definition of deterministic finite automata, we have clearly told that it is a quintuple or a five tuple which had five elements in it. That is, M is equal to Q, which stands for set of states. Then we had summation, which is the set of alphabets. Then we had transition, and then we had Q naught, which is a start state, and F is the set of final states. In non-deterministic finite automata also, the definition remains same. That is, it is a quintuple which has five elements in it. But the only place where it is going to change is in the set of transitions. Now let us see what kind of transitions we are going to get in this particular non-deterministic finite automata by defining each and elements we have in this particular set. Here we all know that M is a finite automata, that is non-deterministic finite automata. Now Q is nothing but set of states. Set of states. Summation is nothing but set of alphabets. Then transition, it is very important because this is the place where it is going to change or differ from DFA to NFA. That is, a transition on any state over a alphabet is going to give you 2 to the power q. In DFA, the result will be only q, but here it is 2 to the power q. What is 2 to the power q? It is nothing but the power set. We will see what is this power set in few minutes. Next, what we have is q naught, which stands for what? It is the start state. And next we have is f, which is nothing but set of final states. So this is how you are going to define a non-deterministic finite automata. Now, let us see how or what is the difference between deterministic finite automata and non-deterministic finite automata quickly. For this, I will take an example of constructing an NFA for any language in which AB is a substring. AB is a substring which indicates what? AB should be there in between. Beginning it can be any combination of A's and B's. After that it can be any combination of A's and B's. So that is, with respect to its regular expression, how I can write it? I can write it like this. That is, A plus B whole star, AB, A plus B whole star. That means what? This is a regular expression which is telling you you can have either A or B. Star is indicating for 0 or more number of times. Listen here, if this is 0, the string will start with AB. Similarly, if this entire thing is 0, the string is going to end with AB. So AB should be there. It can be in the beginning, or it can be in the end, or it can be in between. But AB should be there for a substring. Now, how to construct its equivalent non-deterministic finite automata, we'll see. For that, we are following the same step. First, we are going to write the set of strings, that is accepted strings. What is the first string that is it is going to accept? It is AB, no? right? That is the minimal. If this is 0 and this is 0, AB is the minimum string it is accepting. Now, AAB should be accepted. Then BAB, it should get accepted. ABAB, this also should get accepted. Likewise, so many combinations are there. So we are going to construct its DFA. Let us take its skeleton. That is, it is having AB in it. See, we will start with the state Q naught, which is a start state. The minimum string I'll write. First is A, it goes to Q1. Then what we have is B. Then we have is Q2. Here, the string can end with any number of A's and B's, no? So I'm giving A comma B here. That is, the main concentration for me in this problem is I want this string AB. After that, you can end with any combination of A's and B's. Similarly, it can start with any number of A's and B's now. That's why what I'm going to do, I'll give a self loop on A comma B here. Now see, I'll just remove the strings so that you can see the finite automata properly. Now see, what this is saying is exactly written here in the regular expression. A and B for 0 or more number of times. So here you have 0 or more number of times A comma B. Then you have a substring A, then you have B, and then you have 0 or more number of times A and B in a self loop. Now this is non-deterministic finite automata. Why it is named as non-deterministic means, here, suppose if I ask you in state Q naught, if I take A, where will I go? There are two possibilities. In Q naught, if I take A, I can go to Q naught. If I take A, I can go to Q1 as well. So here you are going to get Q naught, Q1 as a solution. But in all the set of problems that we have discussed in deterministic finite automata, this scenario was not faced. So now let me tell you the basic difference between deterministic finite automata and non-deterministic finite automata. Deterministic finite automata is one in which from any state on a given input symbol, you will always go to a clearly single state only. But in non-deterministic finite automata, as the example shows, from state Q naught, you are going to multiple states on an input symbol A comma on an input symbol A. That is, on Q naught, if I take A, I don't know whether I am going to Q naught only or Q naught on Q1. So this ambiguity will not be there in deterministic finite automata. That is the only difference between DFA and NFA. Now, there is one more question. If I already have a deterministic finite automata, why I should go for non-deterministic finite automata? Because non-deterministic finite automata has some advantages over deterministic finite automata. Let us see what are the advantages we have. First one, construction of non-deterministic finite automata is easy. You can construct a NFA for any difficult problem and later convert it into deterministic finite automata. Third one, NFA is stronger than DFA. So these are the main advantages we have from NFA over DFA. And of course, all the systems will be using deterministic finite automata only, but users can easily construct any NFA and convert it easily to any deterministic finite automata. So first, we will find the easy way to construct it in FA and later we will convert it into its equivalent deterministic finite automata. So this is the definition of non-deterministic finite automata. We have seen example. And in example, we have seen on a single alphabet, it can go to multiple states. That is why in the name itself, it says non-deterministic. And we have seen what are the advantages of non-deterministic finite automata. But here, one topic that is left out pending, what is it? I have to tell you, that is, what do you mean by power set? So this is what we need to discuss. Why the transition is giving power set. Power set indicates the combination of all the sets that you can get in a given diagram. Now see here, in this transition diagram, what are the combination of all the states we can get? Let us quickly write it. See, how many states we have? Set of states. The set of states we have here is Q naught, that is this one. Then we have Q1 and Q2. This is the set of states we have. How many states are there? The number of states is equal to 3. Its power set, that is 2 to the power Q. What do you mean by this? What is 2 to the power 3? 2 to the power 3 is 8. So I am going to get 8 combinations here. What are the 8 combinations? First one is null set. I can write it as epsilon or just null. Let me write it as null only. It is a null set. Next I have Q naught, which is a single set. Then Q2, Q1. Then I'll get Q2. Then we can get the combinations, that is Q naught, Q1. Then I'll get one more combination, Q naught, Q2. Then I can get Q naught, Q1 and Q2. And Q naught, Q1 and Q2. How many we got? Just check. First, second, third, fourth, 5, 6, 7, 8, which is equal to the total number of sets we are getting. So power set is nothing but the combination, the different combinations you can get over the number of states you have in the given diagram. And listen here, when we were writing the transition, I told you, if you take Q over summation, you may get result from where? 2 to the power Q, right? Now see, transition from state Q naught, that is a state, no? Comma, over alphabet A, what you are getting? Q naught on A is Q naught. Q naught on A can go to Q1. So Q naught comma Q1. Is it not belonging to the power set? Yes, that is why we say the result can be from the power set. So this is the main